Okay, thank you very much. We are going to have this presentation done by one of our great colleagues, who is a professor of environment and natural resource economics with over 25 years of academic and industrial experience. His research spans climate change mitigation, natural resource accounting, environmental policy, and health economics. Several publications from him. And if I want to go on, will take a lot of our time. So without much ado, let me invite Professor Daniel Chirufo to take us through what he has for us. Thank you very much. So, Prof. Chirufo.
There's a project being done by RIPS together with the College of Education and supported by the Office of National Statistics, and also where the broad funding is coming from Welcome. What we're trying to do is that we just want to have, the interface between climate change and, some epidemics. And one component is the relationship between climate change and meningitis. Our team is made up of, 4 people technically. Myself, Professor Eric Afodazi from the business school, Professor George Wack, who is the chairman and moderating this session. And therefore, this work was done, by all of us. Let me take the opportunity to also thank, a couple of reviewers who are outside and give us some great sort of insights into this sort of paper we are coming to present now. Let me just take the opportunity and explain to you what CSM is. Maybe many of you have heard about it, but you've never had the time to look at this disease and how it is claiming lives. Now, CSM, or
are you seeing from your system that I haven't muted?
Well, George, please, can you mute your mic?
I have muted.
We can hear you. Right. Good. So CSM is an infection of the meninges, right? The meninges is a protective membrane covering the brain and spinal cord. Now, the disease is usually caused by a bacteria called the Neisseria meningitidis, as you can see over there. And the symptoms are quite, those of you who have been in the northern part of Ghana, the symptoms goes like with a headache, fever, you have a very stiff neck, sensitive to light, vomiting, and the transmission mainly is through personal contacts, through respiratory droplets. So somebody breathes, and then he sneezes, he coughs, and then you have it, and then it spreads. We've had some major outbreaks, okay? And if you look at the disease, it spans in what we call the meningitis belt from Senegal to Ethiopia. It affects many people in that area, and almost around 400,000 people in Africa do have some sort of seasonal epidemics with this disease. In the 90s, right, it was a very significant sort of disease. If you look at the data for 1996, 97, a lot of people died out of this. In Ghana too, the data is there to show. And when we look at this graph here, we see the belt, right? You see the belt. And it's not difficult to see that Ghana, the northern part of Ghana, is also susceptible to this disease. There's a basin, okay? There's a basin that more or less helps to reduce the risk. But the occurrence or the reoccurrence remain high in vulnerable groups. That is, groups that are more or less do have some risk or certain sort of activities that puts them at risk. As I said earlier, Ghana lies on the southern edge of the meningitis belt, and the northern regions like Upper West, Upper East, Northern, they face dry season epidemics during this. So when we look at this map, it also tells us exactly, that where this can be found in Ghana. The outbreak sometimes extend to central and southern Ghana in some situations where it's quite dry. We found traces in a central region, traces in Ashanti region, and even the Brong-Ahafo region, right? I think in 2014, a lot of cases and many people died out of that. Now, the risk of Ghana is shaped by both the climatic triggers not only climatic triggers, environmental and social health system also exposes people to, vulnerabilities. And that's the reason why we need to pay attention to this cerebrospinal meningitis. Now, what is the excellence in Ghana? Normally, we believe or we perceive that, if you look at CSM, if you're looking at the core countries that are being affected by this, we are not part of it. But if you look at the data very well, the reverse could be the case, because if you look at the numbers that is appearing and you compare to some of the, countries in the belts, you can see that we need to be very, very careful. We see the epidemics increasing and linked to climate strains. So more different sort of varieties, are coming out, making it difficult to more or less control. And issues of migration are also, allowing the disease to spread, especially to central region, to the central region. As I'm saying, people have the disease, they move to other parts, and therefore they go with the disease. So I'm saying that we existing studies that we see throughout suggests and are more focused on the Sahel countries, and we see very scarce sort of cases targeting CSM. It is in recent years that we see, or you saw a couple of, I think last year, a couple of works trying to focus on, CSM, but then the attention may be quite divided from what we are doing. So it is from here that we take our strength from and try to investigate deeply when it comes to CSM and climate change sort of a nexus. So what questions do we set ourselves to address with this sort of a study? Do dust-humidity interactions seen in the Sahel apply to Ghana? As I said, in the Sahel region, these have been established, okay? And many of the research that we see today are focused in this region. We don't have very clear works in Ghana that are trying to holistically sort of deal with this question, and that's why we wanted to, investigate it. Then the issue of solar radiation, wind affects, CSM in Ghana's humid area. So these are all variables that have got something. These are all variables that have got impacts, but we are overlooking it. So we decided to have a comprehensive sort of model where we will be able to parsimoniously involve all these sort of indicators and see their sort of impact on them. One thing which many students did not do, it's about looking at the short run and the long run, short run anomalies, and then the long run trends. So when I talk about short run, I'm talking about month to month sort of anomalies and how to respond to it, and how these variables more or less impact on CSM. In the long run, we look at trends and how these variables. So we decided to break it in order to know the short run and long run impacts. Again, definitely, we also look at all the climatic variables in these sort of areas. So this study, taking data from 2010, 2022 as attempts to more or less address these issues. So emanating from these sort of problems, we do have objectives to examine how dust, humidity, solar radiation, temperature, rainfall, and wind influence CSM incidence. Again, more or less, know the differentiate the impacts, short run anomalies, that is month-to-month fluctuations, long-run climatic trends, how do they affect the impacts? And also, one sort of value addition, innovation that we are looking at and that we have very, very interesting results, which has got impact on policy, is interactions. And here we look at two interactions, dust and humidity and dust and temperature. And as very soon I'll be discussing with you, you will come to know that if you look at surveillance system trying to focus only on temperature, it may not be the best surveillance way of trying to deal with CSM. We may have to look at other things like dust that has got more or less constant and significant impact on CSM. So after all this study, in the long run, we intend to provide evidence-based insights that will more or less, strengthen early warning systems. And here I'm talking about the interaction that we look at in terms of dust and humidity, and also try to guide some structural adaptation in trying to, solve the problem of cerebrospinal meningitis in Ghana. So overall, we believe that this study is meant to contribute to policy by linking environmental science with public health strategy. what does the literature say when it comes to CSM and climatic variables? If you look at this table, we look at the work that has been done, and then we try to look at the impact. If you look at all what is here, for example, there is no Ghana study. Okay, you see Niger, you see Senegal. This one was more, the last two was more based on, the Sahara regions. And what we see from these studies is that the first one look at dust and saying that dust will have some sort of a negative impact, together with the second one by Agia, more or less having the same sort of, we see aerosol concentration and temperature also being some sort of significant impacts in the work of Ian Lally. And then when you come to Chen, a very known person when it comes to climate change impact on health, and he more or less again looks at temperature variances, and the work was more or less on global scale, definitely suggesting that, Ghana influence or the impact on such a work on Ghana would be very minimal. Well, Savory also look at humidity, right? Savory also look at humidity and the impacts and the objectives or just are there, and the findings is what you can see in the table. Further, we see that Diop also trying to look at issues of, CSM in the Gulf region, and his emphasis was more on temperature and humidity. All right, and again, Ian Lally and Etel also look at temperature and dust. Why the only work that explicitly focus on Ghana is the one by Dukik, right? Dukik Etel. And here they gave real sort of a statistics, so where sort of impacts, that is the coefficients of temperature and CSM. It is from this literature review that we punch the holes. One, the long run and the short run impacts of these climatic variables on CSM has not, been captured, leaving us a gap. Two, interactions between humidity and dust, interactions between, dryness and dust has not been covered, and the specifics has not been focused on Ghana, leaving us a gap that we need to, discuss. Three, the long run effects. Right, separating the long run and the short effect has not been covered by all these works that focused explicitly on CSM and climatic variables. And it's from here that, again, I said, we get our energy to be able to undertake this study. Before I go on, I would like us to have a discussion on the pathways. That is the climate change and CSM impact pathways. So through which directions, what is the path through which climate change more or less affects, CSM. Look at the graph that I have over here, the chart that I have over here. We have climatic drivers, and these are greenhouse gases. We know aerosols, the increasing the frequency, intensity, and duration of heat waves, etc. And through these ones, we have heat waves, we have droughts, right? We have tropical storms, hurricanes, etc., wildfires, increasing risk of CSM, etc., etc. So these are more or less climate drivers bringing up hazards. Okay. Indeed, we can look at people who are vulnerable, right? Individuals are vulnerable, households are vulnerable, and the vulnerability more or less would depend on spatial nature of the socio-economic issues, the seasonal nature, demographics in the households, sort of a factor that may influence CSM. So, for example, if you are sleeping a lot in a room, what happens is that if it affects one, definitely you are all going to get it. Those are socio-demographical sort of issues. Special issues, if you are somewhere in northern region, the probability of getting this high compared to, somebody in the, southern part of Ghana. Of course, there are also community and population vulnerabilities. So we can move from sort of household to communities where, because of how communities and social systems are constructed, it can rather increase CSM sort of occurrence and then other disease. So the exposure to heat, there is also a high human exposure to heat hazards, which increases the risk of psychological sort of impact. Indeed, I'm tempted to think, and many people have said that the adaptation strategy may depend upon how we deal with these vulnerabilities. Okay, and therefore on the left side you see how adaptation strategies may fit into the loop to allow the pull pathway to more or less form a cycle that we see. It is for this reason that we need to be very careful, because if you are not careful, the cycle completes and then we have a problem. Now, what are the impacts, the psychological sort of impact of CSM? So I said, more or less in the short run, right, we have heat-related illnesses, heat-sensitive illnesses, and there is increased risk of what? Mortality and morbidity. In fact, in the long run, it can lead to blindness and brain damage, since CSM is about affecting the membrane of the brain. Definitely you may have some neurological sort of problems. So these are sort of causal paths with the link between climate change and then CSM, and that gives us the framework for investigating the relation between climatic and environmental variables and CSM. So based on this sort of framework, we try to have a study design that more or less regional in nature. So it means that we are talking about regional data, we're talking about monthly data for all the system regions, and the data spans from 2010 to 2022. Initially, when we put this sort of question there, people were talking about, where do we get the data source? When it comes to the data on CSM, we got it from the Ghana Health Service, and this count data, okay? This count data which we use. The other data, right? Precipitation, humidity, wind, solar, radiation, we use ERA 5. And then the ERA 5 land data, it's global data, operated by, one sort of institution in Europe. And it's for all countries, for all regions. If you have a very good skills, you can go there and extract all this data. When it comes to dust, we concentrate on PM 2.5, PM 10, and then OOD 550, and the data was obtained from CAMS and EAC 4. These are all sort of global data that anyone can lay hands on once you are given the permission. Again, we also try to get data on temperature and precipitation from GMET, and we try to run some correlation between ERA 5 data, GMET, to make sure that the data that we are using is more or less foolproof, and all our correlation results proved positive and highly correlated, suggesting that we are on the right course. So these are some of the dependent variables that you can see over here. So monthly count data, the independent ones: dust concentration, relative humidity, precipitation, solar radiation, wind speed, temperature, etc., etc. Now, we use a negative binomial, sort of regression in our estimation. And what we do is that we start by having a reduced form where we include, climate variables, plus that lags in a parsimonious manner. And then we also go on and add the interactions, dust and humidity, dust and temperature. Doing all this, we control for fixed effects, monthly effects, so that any sort of impact within the month, any sort of impact within the regions that may have impact on our results are removed, helping us that we get a result that are quite robust and that can have some policy relevance. Definitely, with the work of this nature, there is a need to do diagnosis and robustness checks, multi-collinearity tests, residual analysis. We're comparing GMET and ERA 5, etc. We did all these, and all the parameters, led to the fact, or led to the credence that we are on the right path. A sensitivity analysis, right? We could use a Quasar-Poisson, but we saw some overdispersion in the fact that if you look at the count data, what happened is that the standard deviation was quite high compared to the mean, suggesting that there is overdispersion, and it becomes much easier to use negative binomial when you have data that is quite overdispersed. And that said, we use Quasar-Poisson and DLNM to be able to get some sensitivity analysis on the result. Indeed, the results were all in line. So if you look at the result from the Quasar Poisson, DLNM, they were all in line, but just that because of these sort of problems associated with overdispersion, we prefer to go with the negative binomial results. So the model that we use suggests that we interpret the results, in together, right? Unlike other models where you may have to have a coefficient and interpret, each and every coefficient, differently. So here we're just talking about whether it increases and the significance, whether it decreases and the significance, right? So we will start from the individual sort of, variables, and then build on the interactions, bringing out the policy dimension, and then also look at the long run sort of effects. One thing that comes out is that dry dust in the previous month predicts elevated CSM risk. That is very important. So what it means is that dust in the air has significant positive impacts on CSM. So, which we will later come to know when we look at the interactive sort of result and look at the long-term result, then it better allows us to conclude our results. So this is not quite novel. It's in line with theory. Martini and Chiapello, more or less, and also Gares, Garcia, Pando et al., they also identify mineral dust forms as strong short-term epidemics and trigger more or less meningitis, trigger sort of meningitis increase. Now, when we look at relative humidity, we see that it reduces. So more humid conditions reduces CSM. Of course, this result supports, Sultan and Nigeria, and they show that the epidemic activity decline rapidly once humidity exceeds, 40%. And it's in line with what we are predicting, more or less, with the same results as humidity. And if you look at the Northern Belt, whenever there is meningitis and it rains, definitely you see the number of cases of the spread also reducing. Solar radiation has got more or less a positive impact. So when skies are clear, sunny conditions, they coincide with more or less higher incidence of meningitis. All right. Going further, we look at the temperature, right? And we see that the effects are mixed, right? But then it's not very significant, so we may also not want to, pay more attention to that. To that wind speed, that also, shows some signs, but then it's not significant, so we don't want to, pay more attention on it. The key thing we have here, and that has been the novelty that we are bringing on board, is the dust sort of relative humidity interactions. We see that dust impact weakens in more humid conditions and reflecting moisture proactive roles, right? A result that AGR confirmed, and according to the dry dust air synergy, is the key trigger for the epidemics, right? And again, when you look at the interaction between dust and temperature, we conclude that dust effect strengthens moderately under hot, dry conditions. A result more or less, which was more or less also provided by Palmgren and then Ayandale, which the results, the works have already alluded to. Now, at this point, I would like us to really look at now when it comes to the monthly fixed effects, we may not want to, allow it to pay more attention to that since their effects are not significant. At this point, it pays to focus on the key issues that we focus our attention on. And for where we think there is novelty, that should bring about some policy impact for our policy makers. So if you look at the result that we have over here, dust effect intensify in dry, air conditions. So we see that under very low humidity, with a standard deviation of -2, dust surges sharply, and it raised CSM incidence, and this confirmed that compounding hazards of dust and dryness. So when you combine dust and dryness, the effect is quite high. So why is it that early warning systems are focusing only on dryness when dust combined with, dryness gives us a more impact on CSM? And we will see later in the long run effect that dust alone in the long run is not quite significant. And this is where our value addition may be coming from. So the intuitive sort of explanation may be that when the air is very dry, okay, sudden increase in dust strongly raises the case of cerebrospinal, meningitis. And again, when the air is very humid, that stops having that harmful effect. And in fact, the effect flattens, which is statistically reliable. So this is where we are coming from. That early warning system may not only have to focus on temperature, but we also have to pay some impact on dust, and a combined sort of threshold on dust and temperature would be a very good sort of early warning system for meningitis. Again, when you look at this result, what we see is that temperature adds a little moderation. Temperature adds a little. That effect stayed nearly parallel to post-temperature anomalies with only marginal strengthening in hot conditions. If I want to interpret this in very plain words, what this is telling us is that changes in temperature, that is hotter or cooler than normal, don't strongly change the effects that dust has on meningitis. Okay? There is only a small increase in dust effects in hotter conditions. It's not a very long driver. So this is where the novelty or the innovation that we may have to have our policy brief to focus for the Ghana Health Service, and the novelty that we think we need to carry on with this work. Again, if you want to look at the long-term effect, right? The long-term effects, that gives us a very interesting results, which we have to share with you. When we look at this result, what we can say is that humidity and warming are protective. Okay? Humidity and warming are protective because we see that rising humidity and warming lowered CSM risk in line with the work of Sultan and that of Thompson. So if you look at the incident rate ratios, the graph starts from 1. When it goes left, it means, it's very good. When it goes right, it means it's very bad. And if you look at the trends for humidity and look at the trends for temperature, you see that, they lower more or less the incidence rate ratio. But then if you look at something like dust, what happened is that they more or less increase the incidence ratio, as you can see, because the dust is more than 1. And then we do have temperature and the humidity. Looking at the trends, that is the long term, they are all less than 1. What it's suggesting is that in the long term, dust has got significant impact, but the results for temperature and humidity is in the other direction. So what conclusions are we making from these results, which we think policy makers may have to look at it? Dust surges are major short-run drivers, but their effect weakens sharply when humidity is high, confirming the dust plus dryness sort of compound hazard. And this is what we are saying, that early warning system may not have to focus only on temperature, but the combined effects of temperature and dryness. But if you go to the ministry, it's all on temperature, but it is time for it to be more accurate. We focus again on dust. 2, solar radiation and northeastern winds act as amplifiers, sustaining dry season epidemics constantly. Rising humidity and rainfall trends we know are protective. That is quite, it's in line with the literature, and limiting epidemics resistance and align with belts wide ecological sort of evidence. Indeed, vaccination, strain dynamics, and health systems, they remain decisive, and showing that climate hazards interact with biomedical and institutional, sort of factors. So in conclusion, what we are recommending is that we believe that early warning systems should integrate dust humidity monitoring into national health surveillance, and then set alert threshold for dust plus dryness conditions. Currently, the thresholds are only on dryness. We believe that increasing the threshold or including some aspect of dust, then a combination of threshold between dust and dry nets would be in the positive direction and may give us more accurate sort of surveillance as we go on. With regard to preparedness, we have to pre-position antibiotics and vaccines in high risky northern districts, and of course deploy rapid response teams whenever there is a harmattan. And then we also need to maintain our high Men-Afric-Vac coverage, expanding sort of new vaccines, the NMCs, NMW, NMX, and we make sure they align schedules with climate-informed sort of forecasts that we do have. I think I'll thank you so much.